So we're learning about mean absolute deviation, which is also known as MAD, because mean absolute deviation is a lot of syllables, and I'd rather just say MAD, right? So we're going to be learning about this today. So we are going to start on our front page and talk about each different part of it and what it means, okay? So the mean is the average of data. And if we look over here, this is how we find the mean, which we should know because we went over that again last week. Absolute means that it's positive. Means that there's no negatives.
Maybe I should.
You're messing up my video, dude.
I know, I'm sorry.
All right.
Maybe I should take one.
Deviation means distance from the mean. So the mean absolute deviation tells us how far away the data values are from the mean of the data set. So a smaller MAD means that the data values are closer together. And a bigger MAD or a larger MAD means that the data values are farther apart. So basically, if I'm going to reword that into simpler terms, I'm going to say that we are going to find the distance of each data set from the mean. So I find the mean, and then I find the distance of each number from the mean, and then find the distance of that. So we're going to talk about the steps that we're going to take to solve. So if you turn the page, you'll see this page. We have 3 steps to take to solve this problem. What are you doing on the calculator? Find the mean of the data is the first step. The first step we all know how to do. Okay, the second step is we're going to find the positive difference between each number and the mean. What does it mean by difference? What does it mean by difference? Yeah.
Like subtraction, like you take.
Yeah, subtraction. We're going to subtract each number with the mean and find the positive difference. Guys, y'all have got to shut the door when you come in or when you leave.
Yeah.
If the door's shut, then it should stay shut. Okay, then we find the mean of the numbers we found in step 2. So it's basically finding the average, finding the distance between the mean and that number, and then finding the average of those numbers. We're going to do that in just a moment. All right.
Okay.
So we're first going to find the mean of the data set. So we're going to have 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5. So this is basically telling us we record the number of orange Fruit Loops and 8 scoops of cereal. Find the mean absolute deviation. So we're going to divide by 8 because it told us there's 8 scoops right here.
Scoop.
So you should have done 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5 divided by 8. What did you get? Marley? 3. All right. So now what we do is we find the distance that each one of these numbers. Note that all of these numbers right here are the numbers from our data set up here. So I'm just writing these so that it's easier to organize. Okay. So what's the difference from 1 to 3? What's the distance? Y'all call it out.
2.
2. 2 to 3.
1.
2 to 3.
1.
2 to 3.
1.
4 to 3.
1.
4 to 3.
1.
4 to 3.
1.
5 to 3.
2.
Wow.
Make sense?
Yeah.
So now we need to find the sum of the distances. So we're going to do 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2. Is that the right amount of ones?
2, 3, 4, 5, 6.
And it should add up to
10.
10,
I just did.
which all of us should be able to do in our head because we're adding 1s and 2s, right? All right. Now we're going to take 10 and we're going to divide it by the number of values, which is what?
8.
8. So we're going to do 10 divided by 8. And we should get 1.2.
5.
1.25. So our mean absolute deviation is 1.25. Okay, so let's review the steps we just did. Okay, we found the mean. We found the mean for step 1. For step 2, we found the distance between the mean and each point. Then for step 3, we added them all up. And then step 4, we divided by the number of values, which is basically step 3 and 4 is finding the mean of these distances.
Alright.
Okay? So this mean absolute deviation of 1.25 tells me what? Tell me. Is that a big mad or a small mad? That's a small mad. What does a small mad tell me? Christopher?
That the data values are closer together.
Right, the data values are closer together. If I look at my data values, these are pretty close together, aren't they? So the smaller the mean, the closer the data is together. The smaller the mad, the closer the data values are together. The bigger the mad, the farther apart they are. So the bigger range you're gonna have. That make sense?
Yes.
Alrighty.